Hello and welcome back to Apt for You. In this particular video, we are going to discuss a new problem from dynamic programming. And the name of the problem is basically Substrate Sum Problem. Fine. Before we proceed, there is a prerequisite to this particular problem. Now, what is the prerequisite? It is strictly required to have a basic understanding about the 0-1 knapsack problem, right? About the 0-1 knapsack problem, how we write the code for 0-1 knapsack problem, what is the 0-1 knapsack problem, and what was the logic and the concept behind the 0-1 knapsack problem. You need to go through that part. I have already made a uploaded videos on 0-1 knapsack problem, and you can clearly see it that I have uploaded 3 videos on the 0-1 knapsack problem. It is must watch. What is the knapsack problem, how can we solve it using recursion, how it is improved by memoization technique, and how it is improved further by the top-down approach. All these 3 videos are uploaded. The most efficient approach was the top-down approach, and this basically is the backbone of many problems which are basically inspired from the 0-1 knapsack problem, right? So in simple words, there are many problems which can be solved on the same logic that is being used to solve the 0-1 knapsack problem by top-down approach, right? So it is very important that you know what is the top-down approach of 0-1 knapsack problem, how we solve it using the tables that we are creating, how we are solving the sub-problems to finally come out with the final solution, right? So must watch. This video is must watch. Fine. I know it's a bit lengthy, but yes, I have just simply decoded each and every aspect of the problem there of 0-1 knapsack problem, right? So once you watch it, you'll be very comfortable in understanding what we are going to write now. Fine. So having said that, let us understand what is a substrate sum problem. Now, a substrate sum problem, in simple words, it says that you are provided with an array of certain size. Okay, the size of the array is given, the array is given. At the same time, you are also provided with a variable sum. You can clearly see the size of the array is given, the array is given, and the variable sum is given. What you need to do, the objective is to find if there is any subset of this array. Is there any subset of this array which will be leading to a sum of 9? So definitely there are multiple subsets, right? How many subsets will be there? 2 power 1, 2, 3, 4, 5, 6, which is equal to 64 subsets will be there. Out of those 64 subsets, I can clearly see that a subset with elements 3, 4 and 2, or a subset with an element 4 and 5, these subsets have the sum of all the elements as 9, right? So if you can find at least one subset whose sum will be equal to 9, you are going to return what? True or 1, right? True. So this is going to check the subset sum, right? Check subset sum. So you can see is subset sum or not. What is the result return type? The return type is boolean. Boolean in the sense you just return true. If the subset of a sum 9 is present, then return true. If you cannot find any subset of sum 9, you will be simply returning false. Fine. What is the inspiration of this particular problem? So I'm just saying it is inspired by 0-1 knapsack. So this particular problem is inspired by 0-1 knapsack, and I will basically be using the top-down approach of the 0-1 knapsack problem to solve this particular problem. Now before we proceed, I will just simply explain you the 0-1 knapsack problem once again, a very quick overview about how it was working, so that we can just use the same concept to write the code for the substrate sum problem. Fine. So let me just open the problem of 0-1 knapsack. So I hope you have already watched my video on the 0-1 knapsack problem using the top-down approach. So I'm going to explain you the algo of the top-down approach. So what is the algorithm of the top-down approach? So let me just erase this. Yeah, fine. So the algorithm of the top-down approach is very simple. First thing we were doing is basically the first thing, create a table, right? Create a table, because we know the top-down approach is totally based on the table. So we created a table. What will be the dimension of the table? N plus 1 cross W plus 1. What is N? The number of elements in the array. W was the capacity of knapsack. So if you refer to this particular problem, if you just look at this particular problem, we have a weight array which has the items of weight, item 1, item 2, item 3, right? Weight 1, 1, 2, suppose. The profit associated with each item is given in this value array. So you have 2 arrays here, right? The values are 10, 20 and 40. The capacity of the knapsack that we are talking about is basically, so this is the knapsack that we're talking about. The capacity is 2 units, right? So how many units you can fit here? Only 2 units. The objective is to maximize the profit. So you pick up you fill this bag such that you will be ending up in picking up maximum profit elements as possible, right? So you can clearly see manually, if I say that I can just pick 2 or 2 kgs of item, which of the 2 kgs item will you pick up? If I pick up this 1 kg and this 1 kg, then I'll get 30 kg only. But if I pick up directly this 2 kg, I'll be ending up with a profit of 40 kg, right? Much more than these two. So this is the good solution, right? To just pick up this item only, item 3. So instead of picking up item 1 and item 2, this is not a good approach. I can just pick up item 3 directly, because this will give me a profit of 40. Item 1 plus item 2 together will fill 2 kg, but it will give me a profit of 30 kg. So this would be my answer, isn't it? Now how do we get that answer? So what did we do? We created a table in case of 01 knapsack. The dimension of the table was n plus 1 w plus 1. N is the number of items, so always remember. So just always remember that n basically represents these rows, okay? These rows are nothing but the number of items at any instant, and I basically will be pointing to n, and this is nothing but capacity of knapsack, w, column wise. J will keep track of the capacity of knapsack. Now why I am replacing n with I and w with j? The reason is very simple, because we are going to follow the top down approach, and we know that what we do in top down approach, we solve each and every sub problems, right? So we solve each and every sub problems. You can clearly see for each and every sub problem the value of n and w are different. So here you can see the value of n is 0, w is 0. If you consider this sub problem, the value of n will be 1 and w will be 2. That is why we keep variable I and j. That will be basically, indicating w and n respectively, right? N and w respectively. Fine. So after we create the table, you can clearly see I have already initialized the basic sub problems, right? The basic sub problem. So after creating table, what is the next step? The next step was initialization of the basic conditions. Initialization. So how do you think we initialize? So in order to initialize, we will look in the first row and the first column. So if you look into the first row, this just point out to this cell. What is this cell saying? This cell is saying that if I have n is equal to 0, means I have no items in an array, and the capacity of knapsack is also 0, how much profit can I get? So you have no items in the array, the capacity of knapsack is also 0. How much profit can you get? 0, isn't it? Because if you don't have any elements in the array at all, so for all these cells you can see n is equal to 0, which indicates you don't have any item to pick up. If you don't have any item to pick up, irrespective of the capacity of knapsack, you will always have 0 profit, because there are no items to pick up, isn't it? Likewise, if you focus on the first column, you can find out although you have items to pick up, but the capacity of knapsack is 0, then also your profit will be 0. So we easily solve the basic problems by just running a for loop and initializing them with 0. Done. So this part was completely done. So two things we have done: creating a table and initializing it. The third thing that we did in case of 01 knapsack, if you have watched my video, was how do we fill up these cells? How do we fill up these cells? Now comes an interesting part. So in order to proceed with that, now consider this particular cell first. This particular cell, what is this cell indicating? This cell indicates that your size of the array is 1, n is equal to 1, but you know that your original array has 3 elements, but here they are mentioning that you have to assume that your size of the array is 1, so you just refer to the first element. So I'll assume my array is having only one element, that is 1. The first element is 1, right? The profit associated to that is how much? So this is weight. The value associated to that is how much? 10, right? So what do? Do you remember? We say if the weight of this item is greater than j, if the weight of this item is greater than j, what is j? J is pointing, you remember this cell? In this cell, basically I want to find dp of 1 comma 1. This is a sub problem. This is I, this is j. I is 1, j is 1. So weight I minus 1 means weight of 0, means this one element only, right? Weight 1. That is what I have directly written. If weight of 1 is basically greater than j, greater than j in the sense, is it greater than 1, the capacity of knapsack? Definitely not, right? Weight is 1 and the capacity of knapsack, I know j is what? J is nothing but representing the capacity of the knapsack for this particular sub problem, right? For this sub problem, the capacity of knapsack is how much? 1. So let me write the capacity. Suppose w is 1 here, capacity of knapsack for this sub problem, okay? For this sub problem only. So the item I am referring to is 1. The capacity of the knapsack is also 1. So do you think can you pick it up or you can reject it? So I don't think I should reject it. I can pick it up or I can reject it. I have two options. I cannot directly reject it. So else part you will come here. Now you will say that you have two options. Either pick up, pick, or you can reject. Right, this way you can come. Because the item's weight was not more than the capacity of knapsack, which indicates you have two options. You don't have only one option. You have two options. Either pick up or reject. Now we know that whenever we are picking up an element, what are the changes that we are observing? So suppose you have element A, B and C. Remember the knapsack problem. We are standing in front of the rightmost element first in an array. We know that if this element is weight is more than the capacity of knapsack, I simply rejected and I used to come here. Means I have reduced the problem to by 1, right? So that is what I am doing here. If I find out that the capacity of that the weight of that item is more than the capacity of knapsack, I will simply reject this and come here and stand in front of this element. Means I have reduced the problem size by 1. So I minus 1, TP I minus 1, but the capacity of the knapsack remains the same when I am rejecting case. So this is rejecting. I hope you are understanding. Whenever I am rejecting, the capacity of knapsack remains the same. J is what capacity, because I have not added any I have not picked up any element in the knapsack. So capacity remains the same. The only difference is you have reduced the size of the problem by 1 because you are ignoring this element. This element has been processed. Done. But if the element is found to have a weight such that it is less than or equal to capacity of knapsack, then you know that you have two options, because like here, the weight of the item is 1. The capacity of knapsack right now for this subproblem is also 1. So I have two options. Either pick it up and put in the knapsack or reject it. Whichever will give me the maximum profit, I'll go with that. So if you just put the value in the equation, so dp of 1 comma 1 will be what? So maximum of value of I minus 1 is how much? 10, because the corresponding profit of this item is 10, plus dp of I is 1, so dp of 0, and 1 minus again weight of 1, that will also be 0, comma dp of 0 comma j is 1. So this 10 plus this dp of 0 comma 0, we know we have already solved this particular subproblem. Means after picking the element, after you pick up this element, suppose you have only one element, after you pick up this element, you don't have any more elements left, so n will be equal to 0. But the capacity of the knapsack will be reduced this case. Why? Because in this case you have already picked up this element 1, and the capacity of element was also, knapsack was also 1, so 1 minus 1 is 0. So now it is pointing to this subproblem. What is the maximum profit for this subproblem? Is 0. So 10 plus 0 will give you 10. So this entire thing is going to reduce to 10, and dp 0 comma 1 is again going to give you 0. What is the maximum profit in this case? 10. So this will be replaced by 10, right? This is how we were basically solving the knapsack problem. Now I will be basically trying to solve the entire table for those who want me to explore this. Now if you want to refer to this particular subproblem, now how does this subproblem works? So again let me write here. Now this particular subproblem says that if you have only one element in the array and the capacity of knapsack is 2. So if you have only one element in the array, which means which element you are talking about? If you have only one element, means you are considering only the first element. So my WT is focusing on the 1, value is 10, capacity of knapsack. Now since I know this, for this particular subproblem the capacity of knapsack is 2, suppose 2. Okay, but this is actually represented by j. Fine. So what do we do? The element's weight which I am pointing to, the element that I am pointing to, its weight is basically less than the capacity of knapsack. So definitely this part will not be executed. It will come to the else part, which means I have two choices. Either you pick or you reject, right? Either you pick or you reject. So what is the problem here? It is dp of, for this cell it is 1 comma 2, 1 and 2. What will be the value? Directly put in this equation. dp of 1 2 is equal to what? Either you pick up the element. So when you pick up the element, what will happen? You will basically include the profit of 10, plus you will refer to dp of I is how much? 1, so 1 minus 1 is 0, and j is how much? J is how much? 2, and minus the weight of the element is 1, 2 minus 1 is 1, right, comma dp of, you are referring to what? I minus 1 means 0, comma j is how much? 2. So in this case 10 plus 0 of 1, 0 of 1 is how much? 0, so you will get 10 only, and dp of 0 comma 2 will get how much? 0 only. So maximum will be 10 only. This will be filled with how much? 10. I hope you are getting the point. This is how we are basically solving the subproblem. How was this subproblem solved? So basically what did I do here? I have two choices. If I pick up 10, if I pick up this item 1, what will happen? I will be having a profit of 10 plus what are you ending up? You're ending up reducing the size of the problem. Why? Once you know that you have only one element in the array, you picked up this, the size of the array will be reduced to 0. That is why you can see I'm referring to, after picking up, I'm referring to dp of 0, and the capacity of knapsack was reduced by 1, so 0 of 1, isn't it? After you pick up, what will be the new problem? You are having the new problem dp of 0 comma 1, because you have picked up the one element, so you reduce the size of the array, so 1 minus 1 is 0, and the capacity of knapsack was also reduced by 1. Now you have already solved this particular sub problem. You know that you cannot have any profit from this case. Nothing to basically pick up, so only 10 will be the result of this. And if you just simply reject the item here, if you simply reject, then also your profit will be 0 only. You are simply rejecting. So maximum of these two is 10. And likewise, the entire cells were being filled up, right? So now I'll be very quick here. I'll be very quick in solving the entire cells, the remaining cells. So now comes the interesting part. Now for this particular I, I is equal to 2, means now you are considering that your array has how many elements? 2 elements, 1 and 2. Okay, 1 and 1. I'm sorry, 1 and 1. 2 elements. The value will be 10 and 20. Okay, for this particular row, the you know what you are visualizing is that your number of elements in the array is only 2, means the first 2 elements. So 1 and 1 and 10 and 20 is considered. Capacity of knapsack is how much for this particular cell? 1. So initially I am standing at this. Okay, I am standing in front of this. Okay, so what is the value here? dp of, I am pointing about what? 2 comma 1. 2 comma 1. What will be the output of dp of 2 comma 1? So dp of 2 comma 1, you know what you are going to do? You are going to first of all see that weight of I minus 1. So weight of I minus 1 means weight of I is 2, 2 minus 1 is 1. So weight of element 1 means this element. Remember, because the index is 0, 1 and 2. So I is 2 means you are referring to the 2 minus 1, that is the first index element, means this element. Because right now my the array has 2 elements, and you remember in the knapsack I have already discussed, you will start from the rightmost element, right? So first of all I am standing in front of the rightmost element, this is 1. Is its weight more than the capacity of knapsack? False. So I'll directly come here, which means now you have two options. Either you pick up this or you reject this. So if I simply pick up this, then this is what will be evaluated. If I reject this, this will be the condition. So if I pick up, what will happen? Value of I minus 1. So what is the corresponding value of this? 20. Plus, it will be reduced to what? I is 2. To 2 minus 1 is 1. And j is how much? J is again, for this particular cell, j is 1. So 1 minus, basically 1 is 0. Comma, dp of I minus 1. So I is 2, 2 minus 1 is 1. And j remains 1 only. So 20 plus what is the result of this? 1 comma 0. 1 comma 0 result is 0 only. 20 plus 0 will give you 0, 20. So this entire thing returns 20. And dp of 1 comma 1 will return how much? 1 comma 1 is returning 10. What is the good choice? The good choice is 20. Maximum is 20, right? So the answer here will be 20. In simple words, you can understand that what I am doing is basically, you are basically saying that whether I should pick this up or reject this. So simply, if you are picking this up, okay, you know the capacity of knapsack is 1. So if you are simply picking this up, you are in a profit, right? Profit of 20. If you are rejecting this, then means you are rejecting this, means now you are just rejecting it and standing in front of this item. And you know that for this particular problem now it is pointing to which sub problem? I have weight, I have only one element in the array, means this row. The capacity of knapsack is 1, means this column. They are intersecting at which point? This point, 10. You will get a profit of 10. Means if you reject this, you have an option of getting maximum profit of 10 only by picking up this item. So 20 comma 10, what is the good option? 20 means better to pick up this element only. Rather than rejecting and picking up this element, it's better to pick up this element so that you will get a maximum profit of 20. This is how this 20 was filled, right? Now if you focus on this particular cell, this sub problem says that again the same thing. In this case, what they say is you have an weight array 1 and 1. The value is 10 and 20, and the capacity of knapsack is how much? 2, right? Because this cell you can see it is pointing to 2. Capacity of knapsack is 2. So the problem is dp of 2 comma 2. Now how do you solve it? So dp of 2 comma 2 can be solved directly. Now how? It says that if you have an array of 2 elements, so I have an array of 2 elements, these 2, and capacity is 2. So what will I do? I will stand in front of this element first. Its weight is less than the capacity of knapsack. So obviously, definitely, what will I do? This if part will not be executed. right? This will not be executed. It will come to the else part. I have two choices. What? Either you pick up or you reject. So we know that dp of 2 comma 2 will be equal to maximum of what? Value of I minus 1. So value of I minus 1 is value of 20 plus dp of I is 2, so dp of 1, and this will also be 1 because j is 2 minus weight of the current item is also 1, so 1 comma dp of 1 comma 2. So 20 plus dp of 1 comma 1, what will it return? 10. So 20 plus 10 comma dp of 1 comma 2 will return how much? 10. So 30 comma 10, what is the maximum? 30 is the maximum, right? So this will be filled with what? 30. How do you think we will get the maximum? The maximum value can be achieved by simply accepting this item also. If you accept this item, what will happen? The problem reduces to this problem. That is, the capacity of knapsack now becomes 1. W will become 1 because the weight of this was 1. You picked it up. W becomes 1, and the items, number of items also becomes only 1. So 1 comma 1, 1 comma 1. Again, what is the maximum profit of this subproblem? Was 10. So directly you picked up 10. So initially you picked up 20 and now you are picking up 10. 20 plus 10 will give you 30. But if you simply ignore this item, then your problem will be reduced to what? 1 comma 2, because since you are not picking up this item, the weight remains 2 only. So first row, second column, the maximum profit will be 10. So 10. So 30 comma 10, what was the maximum profit? 30, which means it is good to pick up the items. 30. So far so good. Now the last thing. So this video, I think so far we are discussing 0-1 knapsack only. The reason why I am focusing on this again is because after this I'll quickly jump to the substrate sum problem in 3 minutes only. Okay, the entire problem will be solved. Now how do you solve this? In order to solve this, we know it is pointing to the third row and first column. Again, third row, first column means, third row means it is saying that number of elements are 3, which means now you are considering the entire array 1, 1, 2, and the value is basically 10, 20, 40. Cool. The capacity of knapsack is how much for this particular cell? 1. So I am standing in front of this. So I am basically saying that what will be dp of 3 comma 1. So you are standing in front of this. You have what option? You will see that whether the weight of this item is more than the capacity of knapsack. So yes, the weight of this item 2 is basically more than the capacity of knapsack. So what do we do? This will be executed, right? Let me erase this. So this will become true. This will become true because the weight of the item is more than the capacity of knapsack. So what is being returned? Return dp of I minus 1 comma j. So dp of 3 comma 1, 3 1, it will say return dp of I minus 1, means 2 comma j, which is 1, which means since you cannot pick up this element because the capacity is limited, I will reject this item and I will stand in front of this. So if you stand in front of this, means you are reducing the problem to having an array of size 2, means second row, and capacity 1, first column. What is the maximum profit you can get from that? 20. Directly you can write 20 here. Simple, isn't it? We have directly solved this particular problem. Now if you refer to this particular cell, it talks about dp of 3 comma 2. Okay, dp of 3 comma 2. Now it's very interesting. So dp of 3 comma 2, which means dp of 3 comma 2 means 3 elements are present, means you have weight array 1, 1, 2, value array as 10, 20, 40, and capacity of knapsack w is again 2, right, for this cell. What is the thing? I am standing in front of this and I am saying whether this item's weight is, because I know that in knapsack what do I do? Whenever you are given with an array of elements, you will stand in the rightmost element. You will stand in front of the rightmost element and you will basically ask yourself whether you can pick this element or not, because if this element is more than or less than knapsack weight, knapsack capacity is 2, this element is 2, so definitely you cannot reject it simply. You have two options, either accept or reject. You cannot directly reject. You have two options, means this thing will become false. You are going to the else part because you have two options, either accepting or rejecting. What if I accept this? So we know that it is nothing but dp of 3 comma 2, and it will be equal to maximum of, after accepting, what is the profit I will get? So if you accept this item, profit is 40. 40 plus, you will be left with what? dp of I minus 1. So I is 3, minus 1 will be 2, means you have two elements in the array, but the capacity will become 0, isn't it? Because right now capacity of the knapsack is 2. This element's weight is also 2. If you simply pick it up, then it will be reduced to this problem with 2 elements, but the capacity will become 0. And you know that for 2 elements with capacity 0, the profit is 0. So 40 plus 0, this will be 40 plus 0 equal to 40. But if you simply reject this element without picking up, the problem will be reduced to these 2 elements with a capacity of how much? 2, because I have not picked up this element, I am just rejecting it. So 2 elements and the capacity is 2. 2 elements, capacity is 2. Maximum profit is 30. 30. Which of these will be maximum profit? 40. 40 will be printed here. I hope you got the point. This is how the knapsack problem was basically working out, right? And this is how the table actually works. Now the inspiration from here is, how basically do you think can we solve the subset sum problem from this particular examples, right? So what was the algorithm that we discussed? Declaring the item here. So this was basically what? Declaring the array, declaring the matrix. Okay, we declared the matrix, we did the initializations, and I hope you have understood how it is working. Done. This was the third step. Now if you talk about the subset sum problem, just focus on this particular entire, this entire thing here. You are provided with the weight matrix, value array, weight array, the capacity of knapsack, and we just designed the matrix. Now if you look into the subset sum problem, okay, this problem you see here, we are now provided with only the weight array is not there. Instead of weight array, what we have an array of integers, right? Instead of w, what we are saying, we have a sum. Okay, and now this particular problem says that in this array, you have to check whether a sum of 2 exists or not, a subset of sum 2 exists or not. So what was the first step? The first step was to declare a matrix. So how do we declare a matrix? The same formula that we used here. So let me just copy this here from here. So this thing is all about copy paste. Sorry, I think, yeah, it's fine now. So I am just copying and pasting the knapsack problem code here. Okay, what are the changes that I'm going to make? So we know that instead of, you don't have a value array at all here, you don't have value array at all, you just have an weight array. You can assume the weight array to be equivalent to the array here. You have it. The capacity is not here in this particular problem of subset sum. You don't have the capacity of knapsack. Instead you have what? Sum. Everything working will be remaining same. Now what do? We declare this. Since we declared this, so after declaring, we successfully created this array, this matrix. What is the next part? The next part is initialization. In case of 01 knapsack, you are initializing in this format, but here there will be a slight change in the initialization code. How do we initialize? We know how to initialize. We will just picking up a sub problem and we will ask ourselves, what is this row wise? Row wise is the number of elements in the array. I will keep track of that. Column wise is basically the sum that we need to find, and j will keep track of that. So this sub problem says that if I have no elements in the array, can I get a sum of 0? Definitely the answer is true, because an empty sub array always has a sum of 0. So you can get it true. This sub problem says that if I have no elements in the array, can I get a sum of 1? The answer is false, because if you have an empty sub array, you don't have any elements that will lead to a sum of 1. False. Same for this also. In an empty sub array, you cannot have a sum of 2. This will also be false. Consider this entire column. Consider this sub problem. The number of elements in the array is 1 and you need to find a sum 0. Do you think it is possible? Yes, it is possible by just taking the empty array. Means I will not pick up this element at all. True. Number of elements in the array is 2 and you need to find a sum of 0. Do you think you can find? Yes, I will just ignore all the elements and take the empty array. True. Here also it will be true. Like number of elements are 3 and you need to find a sum of 0. You can definitely find by just taking the empty array. True. Means there exists a subset whose sum is 0. Okay, there always exists a subset whose sum is 0. Isn't it? The empty subset you can just take. Fine. Cool. So this is how we are going to initialize. So there will be a change in this code, the initialization thing. We are just going to replace it by, now let us just write the code parallelly. So what is it that we are going to write here? So I hope I have not erased everything. Cool. Fine. So what I am going to write, I am just going to do the initialization like this. How did I write true here, false here? So for that I am just going to write here. First of all, what did we do? We declared a matrix and it is same as dp of n plus 1. Just instead of w plus 1 I'll write sum plus 1. Done. Next step was initialization. How do we do that? I and j was taken. I'll run a for loop for j is equal to 0. j less than equal to sum j plus plus. And what will I do is dp of I know that the first row, entire first row has to be filled with false first. So how do I do that? Entire first row means dp of 0 j equals to false. Done. And the entire first column should be filled with true. So for I is equal to 1, sorry 0, I less than equal to n, because I is keeping track of n, isn't it? I plus plus. What will I write? dp of I, and you are talking about the first column only, so 0 is equal to true. Done. And sorry for this, this will not be integer type matrix, this will be a boolean type matrix, because we are filling it with true and false, right? Done. What next? After the initialization steps, now we are going to traverse each and every cell in this particular matrix, isn't it? In the matrix that we created, in this matrix that you created, so far we have just completed the initialization steps. I wrote the 2 lines, I completed the initialization step. Now I will be solving each and every sub problem of this. So for that, what I am going to do, I will be traversing every row, every column. So basically 1 to n and 1 to sum, isn't it? The nested for loops. So that is why I am just going to write here same thing as 0 1 knapsack. For I is equal to 1, I less than equal to basically n, I plus plus, nested. For j is equal to 1, j less than equal to n, sum, sorry, because j is keeping track of sum, j plus plus. Now what do? We are just going to copy the same code of the 0 1 knapsack. So what was the code of 0 1 knapsack here? This part, isn't it? This entire thing, you can see I'm just copying it and pasting it. Copying and pasting. That's the beauty of this particular problem. So copy and paste. I'm not going to do anything new. What was the difference? Just how we initialized it was little bit different. The structure remains the same. This thing is also same. What I'm going to make a change. We know that we don't have any weight array in the subset sum problem. Instead of weight array, what I have array, ARR. I let it. You have j, it's fine. Here you have ij is equal to I minus 1 j, it is also fine. Here you don't have anything called value I minus 1, so I'll just reject it. I'm not going to play with it anymore. You know that you don't have weight, you have array, so ARR. And this thing is also fine. And one more thing, we don't want to return anything called maximum, right? We are not interested in returning any maximum value, because we know that the return type of the function is boolean, and moreover we are interested to check if there exists a subset sum or not, right? Subset sum or not. Now we know that we have two options, either pick up the element or reject the element. Like in this case, this is simply rejection. This is simply rejection. And what is this? This is accepting case, and this is rejecting case, right? In accepting case, we are just accepting the element and reducing the size of the problem. You can see I minus 1 and j minus array I minus 1. And in simple rejection case, the capacity, that is the sum, remains the same, because you are not including any element in the subset, but the size of the problem is reduced, right? That is what, now this is same as this. Rejection case are same. I'm not interested in finding the max, so I'll just delete this from here. So I'm not interested in finding anything called max, so just remove it from here. Now I am interested in finding whether by accepting the element I am getting true, or by rejecting the element I am getting true, right? This is what I am interested in finding, whether accepting the element is giving you the subset sum, or rejecting this element rejecting a specific element is leading to the subset sum. Okay, now if you find out that, okay, if any one of this case is returning true, then this entire thing will become true, right? This is the accepting case and this is the rejecting case. The only thing is I removed the max, I replaced it by odd. So that I'm interested in finding whether by accepting this element I'll be ending up with finding the subset sum, or by rejecting the element you will be ending up finding the subset sum. Okay, you're just interested in that, so I'm using the or operator here. Okay, and if you just find out if either by if any one of them is returning true, either this is returning true, or say suppose only this is returning true, which means you are basically going to say that dp of ij will be equal to true, means you can find the subset sum. All right, and as always we always return the value in the lastmost and in the extreme cell, is in rightmost cell. If you just pay attention, we always return the value present here, isn't it? The this value, which is nothing but n comma sum. This is what I am going to return here. So after the for loop I am going to return what? dp of n and sum. Done. So everything is fine here. So subset sum problem should work. Let us compile the code. I hope you are not doing any mistake. So let me just write it in braces. Sorry. Yeah. So compiling the code, assuming no silly mistakes, this should definitely work. So yes, let us just submit the code. So you can see the problem has been successfully solved. I have basically practiced this many times, so I'm not getting any score because I've already achieved the score. I've already got the score. But anyway, the problem has been successfully executed, and this was the basically the subset sum problem. Now if you are interested in seeing how is it working, so now I can explain you the working. So how will I explain the working? So let me just take the snap of this particular code. So just give me a minute. Alright, so this is the snapshot of this code. Let me just focus on this part only. Yeah, so now we have the code of the subset sum. So now we basically we created this table. You can see the table is created. We completed the initialization part also. Now we will see how is this working. So very simple. Focus on this particular subproblem. This subproblem says that you have a number of elements in the array as 1, means only one element. And what is the element? 1, the first element. And you need a sum of what? So the array has only one element, and you need a sum of what? This cell sum corresponding you need is 1. So if this item's value is greater than the sum that you need, you will simply reject it as per this condition, right? If the value that you're pointing to has the value greater than the sum that you need, you will simply reject it. But I can here see that it is less than or equal to sum, which means you have two options: either you include it into the subset or you reject it. So dp of, we know that this is nothing but 1 comma 1 1 1 will be giving what? Check whether you can solve this particular subproblem, means after accepting this. So if you accept this one, then you are reducing to what? dp of 0 0. Or if you simply reject this one, means if I am accepting this one, I know that I am reducing the size of the problem, because right now I have number of elements as 1. If you picked up this element and put into the subset 1, what happens? Your sum will be now reduced to 0, and your n will be reduced to 0. So 0 comma 0, this is the new problem. 0 comma 0, you can see. Or if you simply reject this item, so if you simply reject, which means you are just reducing the size of the problem to 0, but the sum required is still 1, because you're not including it in your subset. So which of these do you think are you getting true? So dp 0 comma 0 is always giving me true, or dp 0 comma 1 is giving me false. True or false will give you true. Hence this particular value says true, which means yes, it is possible to get a sum of 1 if you are just picking up the first element of the array. If you have only one element in the array, that is 1. Done? Cool. Now let us focus on the second example. So what I'm doing, okay, I'm sorry, I think okay, I think I just need to erase this. So yes, so the first cell is already filled, right? So no worries about that. Fine. Now let us consider the next cell. What is the next cell? Okay, so just this has been erased, so let me just write this. This is nothing but dp of I comma j. Fine. So the next cell is this one. What is this cell saying? Can you get a sum of 2 if you just have one element in the array? Now what is the one element in the array? I'm referring to only one. The sum I need is 2, and I have only this element in the array. What will you check? Whether this element is greater than sum. Is this element greater than sum? No. Which means you will move to the else part. Now the problem is dp of 1 comma 2, right? Dp of 1 comma 2. So how do you think we can solve it? So basically dp of 1 comma 2, we know that what we can do is either we can pick this element and put into the sub array, or we can simply reject it. So if you simply pick it up, you have two options. If you pick it up, what will happen? If you pick up, the problem size is reduced to 0. Sum will be reduced to how much? 1, because this is 1, you need 2, 2 minus 1 is left. So now basically you are referring to what? dp of, you need 1 comma 2, so you are referring to dp of 0 comma 1, or dp of, if you simply reject it, then what happens? The value will be 0 and sum will remain 2 only, right? So dp of 0 and 2. So dp of 0 1, what is the value? 0 1 means this particular subproblem will return you false, or dp of 0 2 will return you false. So entire result will be false. it is obvious that if you just have only one element in the array, that is this one, so you just have one in your array and you need a sum of 2, definitely it is not possible to get it, right? You can see the answer is matching, it is false, right? Now similarly, if you consider this, so this is saying that you have now to consider 2 elements in the array. So now you have to consider 2 elements in the array. So fine. So this was what? False. Now you are considering 2 elements in the array, which means 1 and 1. This is the array now. Sum you need is how much? For this cell you need 1. So basically what will I do? I will stand in front of this item. Is this item more than the sum? No. Then you come to the else part and you evaluate by this. Means either accept this item or reject this item. So dp of 2 comma 1, isn't it? This is 2 comma 1 will depend on what? If I pick up this item, and put into my subset, so what will happen is you are reducing the size to 1, right? So it will become dp of 1. If you pick up and put here, the sum will be reduced to 0 and you have one element in the array. So it will be reduced to 1 comma 0, isn't it? Or if you simply reject this item, the sum will still remain 1 only and the size will be 1 comma 1, right? Size is reduced to 1, sum is still 1 because you have not picked up this item. So this subproblems you have already solved. 1 comma 0 will give you what? True. And dp 1 comma 1 is giving you what? True. Obviously you are getting the result true, which means if you are picking up these 2 elements, if you have an array of these 2 elements only, it is very easy to get a sum of 1. Obviously you can see subset sum 1 already exists, so it will return true. Likewise for this particular cell, you are considering these 2 elements in the array, you need a sum of what? 2. So by evaluating this, what will it return? It will return true. You can easily get a sum of 2, right? By evaluating this you can easily see, right? So so I am just explaining you in very detail. This was false, this is true, and it is very obvious. If you are just considering 2 elements of the array, 1 1, and you need a sum of 2, so what will I do first? It's very simple. You just pick it up, right? If you pick it up, what happens is you put into your subset. So now your problem is reduced to what? If you pick it up, it will become basically, the problem will be reduced to 1 and it will become 1. So dp of 1 comma 1. What you need? dp of 2 comma 2. So you pick this element, means it becomes dp 1 comma 1 or dp of, if you simply reject this item, then the problem will reduce to size 1, but the sum will still remain 2. So 1 comma 1 is giving you what? True. You got at least one true, means this result will be true only, right? Likewise, if you solve this particular case, you are picking all the elements in the array, right? You are considering all the elements in the array, you are standing in front of this item. The capacity of knapsack is how much? 1. So it is greater than 2, isn't it? This case, you are standing here. The capacity of knapsack, the sum you want is 1. The sum you want is 1, but the item you are pointing to is 2. So what happens in this case? You are just going to execute this code. You are going to reduce the problem, means by ignoring this item. You just ignore this item and consider this problem, considering 2 elements and the sum you need is 1. So dp21 will return what? True. So obviously this will be true, which means if I have these 3 elements and I need a sum of 1, is it possible? Definitely it is possible. We have already solved it with 2 elements. Now I know that with 3 elements, I am standing in front of this, I need a sum of 1. I cannot pick this up element because this element is more than the sum. I will reject it. Rejecting it means reducing the size to an array of size 2 and you need a sum of 1. Array of size is 2, you need a sum of 1. True. It will return what? True. What the point? Coming to this particular problem, 3 comma 2. So you have all these elements and you need a sum of 2 and you are standing in front of this, right? So what was the value actually? It was 2 only, right? So definitely this will not be executed in that case because it is less than or equal to 2. Now what we are going to do, either you accept it or reject it. So if you pick up this element, what will happen? If you pick up this element, then dp of 3 comma 2, if you pick up this element 2 in your knapsack, what will happen? Your number of items will be reduced by 1. The capacity of knapsack will become 0 because you need a sum of 2, right? You need a sum of 2. You need a sum of 2 and this item is also 2. So 2 minus 2 will be 0. Or dp of, if you reject the item, so you just reduce the problem to 2 and you are rejecting, but means you need a sum of 2. So you know dp2 of 2 will also give you true only. dp2 of 0 will also give you true only, right? So in any case you will get true only, and we are returning the last value here. Last value, you can say return dp and comma sum. what will it return? It will return true, which means yes, it is possible. If you have an array of size 3, 1, 1, 2, it is very possible to get a sum of 2, because the last value is indicating true, right? So that was the intuition behind this problem. I hope this video was helpful. In case of any doubt, please feel free to put it out in the comment section. Just like, share and subscribe. And this is how we can basically use the concepts of the 0-1 knapsack problem to solve this particular substrate sum problem. Now in the following videos, I'll be coming up with more videos which are basically an inspiration of the knapsack problem. So that's it from my side. Thank you.